We are facing a major transformation. The world is turning electric fast. This is a good thing.
The point is, it's a lot. And batteries will power our future. Our demand is just going to grow and grow.
So, we need to learn to use them in a smart way.
We also need to face the fact that resources are limited.
So why drill and mine more than necessary when it's better for the planet if we recycle and reuse?
So why don't we? Because it's difficult? That can't be an answer. Yes, it's a challenge, but that's the nature of doing great things. Before we recycle anything, we must focus on prolonging the life of products and batteries, being creative, finding new areas of use. When they finally reach their end of life, we must recycle them sustainably, so they can live on in other products. It's up to you and me to make a difference. We must work smart from the start with product design, so that recycled and reused products meet the high expectations of consumers.
If we combine our expertise, we can create recyclable products that can be turned back into new resources.
Together, we can create 100% circularity. It's going to be an incredible journey. Are you ready?
Hi, and a warm welcome to this event that we've called Discover the Future of Battery Recycling. We are broadcasting this live from Stena Nordic Recycling Center in Halmstad, Sweden. A snowy day today, which is one of Europe's largest and most modern facilities. Hundreds of thousands of tons of used cars, electronics, plastics, cables, and other items are recycled here every year. Today, you will hear about this facility and the processes that are here, but maybe more important, about what's being built for tomorrow's battery recycling. You will also get an outlook from partners and get insights from Stena Recycling's own specialists. My name is Frida Zetterström, and I will be your guide through this an hour and a half long seminar. And I'm very happy to see that so many of you guys are logging on now and that so many have showed an interest to join us here today. We have more than 1,200 enlisted participants from more than 5 countries. And with us, we have everything from manufacturing companies to retailers, students, and politicians. And this wide variety of participants shows only just how important the topic of electrification and batteries really is. There's an incredible amount of writing and debate going on about electrification, not only here in Northern Europe, but all over the world. And throughout this seminar, we will, in different ways, follow the journey of the lithium-ion batteries from the design table to becoming a resource for tomorrow's battery manufacturing. Here, you see a high level of today's agenda. As you can see, we'll discuss the challenges and the opportunities of ongoing electrification. It affects us all, whether we manufacture, sell, or use these electrified products. The topic really engages. So, let's get started. First, I'd like to welcome Kristoffer Sundsgård, who heads the Stena Recycling Group with recycling operations in 7 countries. Hey, Kristoffer.
Hey, thank you, Frida.
I said welcome, but it's actually you welcoming us all, huh?
Indeed.
Kristoffer, the industry faces several challenges with legislation, safety, sourcing raw materials for batteries, and more. How can you, as an international business group, address these challenges together with the industry, you'd say?
Yeah. First, Frida, I would say that I think everybody is aware that a lot of products today contains batteries, and it had just started for the automotive industry. And we, Stena Recycling, has a profound history and legacy when it's come to recycling and reuse of components, materials, and products from the whole industry, not least the automotive sector. And as you mentioned in the introduction here in Halmstad, we have built a state-of-the-art recycling facility that makes it possible for us to recycle today's cars well above 95% recycling rate. So we'll use our present infrastructure with more than 170 recycling facilities in Northern Europe, with a really competent people and really efficient logistics system to collect these batteries and products as close as possible to the last owner, to the last consumer. But in addition to that, we will of course also build up new capabilities and develop new processes, such as mechanical treatment, recycling of batteries, and reuse applications of batteries. But about that, you will hear more from my colleagues during the day.
Yes, we have a jammed day for today. But you mentioned Northern Europe. That's where we are right now in Halmstad. How would you describe the conditions where we are here to meet the challenges and opportunities that actually comes with electrification?
Yeah, I think in Europe, or particularly in Northern Europe, we have a strong automotive cluster here, and where we have a history of good collaboration between the OEMs and the sub-suppliers and so on. We're working really hard with quality, continuous improvements and so on. And now we're going to build a new value chain around electrification, and not least around the circular solution for batteries. And here we, Stena Recycling, has defined collaboration and partnership as key success factor for us to building our part of the value chain. And on the same note, within the European Union, we will face tougher legislation. I'm thinking about the battery directive, where it stipulates that we have a certain amount of recycled materials in new batteries being produced in Europe. Also put some requirements when it comes to traceability and so on and so forth. I think it's really important here that we collaborate in the whole value chain, from the battery producers to the manufacturer of trucks and cars, to the retailers and to the recycling industry, to come up with good and efficient solutions. So once again, I would like to emphasize collaboration and partnership is crucial.
Yeah, I was just going to say collaboration is something that we totally will come back to during this seminar. What are your expectations for the upcoming hour and a half?
As I said in the beginning, I mean, recycling is very much our core, and we have been working really hard the past year to fully understand the electrification and the impact it has on our business, to fully understand the material content in the batteries, find reuse applications, how to recycle the batteries. So I hope today that we can share some insights, share our knowledge regarding this, and also share our strategy when it comes to collection, recycling, and reuse of batteries. And finally, I also hope that we can aspire to create some real partnership and build true circular solution around batteries. So I'm really looking forward for today's sessions.
Collaboration and inspiration, huh?
Indeed.
Thank you very much, Christopher, for your helicopter perspective. And before we are moving on, a few practical things. The whole event will last for approximately an hour and a half, and we will have a short break just about halfway through where you can stretch your legs or fetch a new cup of coffee maybe, or get some fresh air. And if you do have any questions during the event, you are welcome to email Stena Recycling at info@stenarecycling.com. Some of the questions might be answered throughout the seminar, of course, but all answers will be gathered in a Q&A and that will be published on the event website. But now, it's time to take a closer look on what's actually happening in the recycling and reuse of batteries today. So therefore, I say welcome to Per Håkansson, who is the head of electronics recycling, Marcus Martinsson, business area manager batteries, who leads the development of battery recycling, and also Rasmus Bergström, CEO of Battery Loop, which develops energy storages of batteries from electrical vehicles. I said welcome, but you guys you're welcoming me here, huh?
Welcome.
Good to see you guys. Pat, you are dealing with big volumes of used electronics from all of us. I mean, there are laptops, cell phones, screwdrivers, and more. And these all includes batteries, right?
Yeah. Here in Sweden, we treat around 100,000 tons of used electronics, and globally in Stena Recycling we have around 250,000 tons. But I would like to explain a bit about the recycling process. So the recycling process of electronics is built on something called the WE directive. And WE stands for Waste of Electric and Electronic Equipment. And it's an EU directive that puts some pressure on the producers. So they need to take responsibility for collection and recycling. So when we, as customer to the producers, have used our products, the responsibility still lies at the producer to collect the material and to recycle the material. And that's where Stena comes in, to help the producer with the collection and the recycling. So the material comes into our what we call first treatment plants, where we dismantle the material, taking out the hazardous waste and batteries according to the WE directive. And then we have a flow of material that we treat in our mechanical treatment, separating metal and plastic, which we then can circulate into new products again. But if we jump back to the battery part that we have taken out in the first step, we then send that to what we call the battery sorting. And that you will see a video of it a bit later today. But in short, we separate it in different chemistries and battery types.
Okay. Well, Marcus, you are working on the more technical, advanced part of recycling, these small batteries that we hear Pat talk about, and the larger batteries from electrical vehicles. What's going on in that area?
Well, there is a lot of things going on, and foremost, I would like to circle back to what Christopher just said, and it's about the new EU legislation regarding batteries, and it will hopefully be in place this winter. And what is very exciting for us is that it takes, and it's instead of being a sole waste legislation, and then you have on the other side a product legislation, it mixes the two of them. And I think that is a key enabler to create true circularity. We cannot think of the material as a product and then have a firewall and then think of it as a waste. We have to connect those two in order to create circularity. This legislation also put forth pretty tough demands on recycling levels. And that is very welcome, I think, because, and it's about due time. It is actually a bit late, I would say. But as an example, this new directive or legislation will put the demand in the future around 2030 that 95% of the cobalt content of a battery must be recycled. And the same goes for the nickel, and then there are demands for lithium. And from our perspective, we are looking and investigating capacities in order to reach those levels already now, next year, or a little bit further in the future. So we are aiming pretty aggressively to reach the 2030 demands already now.
Good. But not all lithium-ion batteries go straight to recycling, right? Rasmus Bergström from Battery Loop, you deliver energy storage solutions made from reused vehicle batteries. Please explain to us why we need energy storages.
Well, I could answer very shortly. Drive to net zero. But I think what is happening in the market today is we are going for electrification. Many of the different car manufacturers go full electric. We have commercial vehicles going full electrics. We buy a lawn mower that is battery driven. So I think that change of consumption will of course generate a lot of batteries, which means we need to charge them as well. Second thing is that the production side is going renewable, which means we are having windmills, we have solar on the roof. Today we have snow here, which means, okay, how can we store the energy to use it when it's required? And of course, if you look at the waste hierarchy, we should use things, we shall reuse things, and then we should recycle them. And what we are believing, to have this circular story and the circular solution, we are looking at what type of batteries can we reuse before we recycle them. And of course, if we take a huge car battery from a full electric vehicle, we're talking about 700 to 1,000 kilos. And of course, if we build them together and we put them in an energy storage, it's like a spa treatment for a battery compared to a vehicle. But what we can then offer is we can then store the energy and use it when it's required. When you need to charge your vehicle, or Marcus needs to charge his vehicle, or the building needs to utilize the energy. The production side is changing so much that it's very important that the frequency on the grid is quite stable, because otherwise all the equipment out here will actually stop. So what we can do as well is to utilize the energy that is in the batteries to stabilize the grid.
We all need the batteries and maybe a spa treatment as well, huh?
Yes.
Per, what trends do you see linked to electrification?
Yeah, if we dig in our big piles of electronics, we can see that the cables is starting to be replaced with batteries. And if we dig a bit deeper in the products, opening it up and looking at the chemistry of the battery, we are used with the alkaline and lead in many products. And this is now replaced with lithium-ion batteries. And with the increasing amount of lithium-ion batteries, the risk of handling it also increases. Because a lithium-ion battery is much more unstable compared to an alkaline battery. So the risk is increasing, which means that we need to work in a different way. So together with the producer responsibility scheme in Sweden called Elkretsen, we are working with separating the material or products on the municipality waste centers. So when you go and throw away your old phone or something, if it's a battery inside, you put it in one cage, and if it's not a battery product, you put it in another. Then we will have a concentrated flow with battery products, which is reducing the risk in the whole chain, so in the logistic chains. And when the products come into us, we know that this is a cage where we have a big content of batteries.
And I think just to underline what Per just said here, I think that the earlier we can take actions to keep the waste pure, the better it is. Recycling is pretty simple. Shit in, shit out. It's as simple as that.
Yeah.
And if we mix everything in the beginning, it will be very difficult to create true sustainability and true circular loops. And there is also another thing I would like to mention here that is of vital importance, and it affects everything, both the product side and the waste side, and that is information. We must start to share information and create traceability throughout the value chain, so we can keep track of the sorted qualities from our customers through our production lines to the next step, which in our case would be Johnson Matthey's refinery process for battery materials, back to the battery producers. And only by keeping a good track of the information, we will be able to create true sustainability and circularity systems.
Traceability is key, huh?
Yes.
Rasmus, the energy system are changing. You said it before, and the automotive industry is also changing. What does that mean when it comes to the reuse of battery world? That's changing too, I presume?
I would say, I mean, we're just in the start of this. I mean, when an OEM puts an electric vehicle on the market, of course, we should utilize that product as long as possible in its first application. Then, when it's possible to reuse it, we should reuse it. And I think this is what we have found out in Battery Loop and what we're doing. I think everything is driven by two things. We go for renewable energy, which will require that we store, because it's not always wind, it's not always sun. That will require energy storage. Either we do it with the reused batteries from Marcus and Per, or we take new batteries because it's required. So then it's better from a CO2 perspective, a sustainability perspective, to reuse them. Regarding on the user side, we're also changing. Where shall I charge my car going back home? I need to do it somewhere. Where shall we charge the building? How can we take down the peaks? Because everyone is putting on the stove at the same time. Everyone is putting on the charging of the vehicle at the same time. So we need to get down the peaks and stabilize the grid. So I think, again, we are in the beginning. We see big changes all the time. When we started this back in 2018, we said that we have a new truth every 6 months. Now I would say we have a new truth every 3rd month because it goes so quick. And it goes from real estate owner to energy companies like windmill parks.
Hold that thought of the real estate owner. We'll get back to that in just a few minutes. But a question to all of you. How can manufacturers that might be watching right now benefit from what you guys learn in the recycling and reuse process on a daily basis?
Well, if we look again, I like the big piles, so I will get back to that. If we start to dig in our piles and team up with the manufacturers, we can separate their product, building an understanding of what's failing with the product. Is it the product itself or is it the battery? Maybe it's the product and the battery is okay. So then we can send back the lithium-ion battery to the manufacturers and have it in a new product again. I think that's one thing that we can do together with the manufacturers.
Yeah, I totally agree with Per. It's very important with information sharing and then also long-term cooperations in order to create industrial effects, positive industrial effects.
But Marcus, I know there's a lot going on in the market, of course, and the demand on battery management are increasing. What would you say that Stena Recycling can contribute to the entire value chain?
Yeah, definitely. Our processes will allow us to circulate back material from an end-of-life perspective, where the energy storages of battery loop is depleted. Then we will take them back, and we will be able to break down the materials and then sort them and refine them and put them back into new products. And I think that circularity is the greatest contribution we can give to the entire value chain.
And Rasmus, one last question, and that leads back to what you said before. I think it might interest many out there who are watching right now, because everyone uses buildings, for example, for different purposes. How can an owner of a real estate company, for example, benefit from energy storage?
Well, a couple of things then, and again, I will divide it in two areas. It could benefit to secure that the tenants can actually charge his or her car when needed, because we're going electric. We should buy electric cars based upon this. We can also secure that the real estate owner is taking down the peaks. We just had a discussion here in the group before we started regarding what is actually the peak price in Sweden now, and it's very, very high. And of course, if we can take down those peaks, we will lower the cost. So the real estate owner can actually earn money on the parking. Tenants becomes happy because I could charge my car. 2, a real estate owner could decrease the cost for the peaks. And on top of this, actually sell back into the grid, because of this changes in renewable in the production side will actually require that you could, or possibility to sell back into the grid. So I would say 3 possible streams of revenue for a real estate owner. That's what we do. And if I may, I would like to just add, I think what we can contribute to as well, looking at the different knowledge we have within Stena on the recycling activities and the reuse activities, and the network that Christopher was talking about, we can actually, in many ways, give more or less a one-stop shop on our activities for an OEM or a real estate owner.
I know you guys have so much to say and you have so much knowledge, but we are limited in time. But thank you so much for sharing your knowledge so far. And I hope you guys in the audience enjoys this as much as we do. There's so much to learn about batteries. But let's not just talk. Let's take a look at how Stena Recycling handles batteries in reality. Anna Sundell, who is the sustainability manager for the Stena Metall Group, will take us to a sorting plant for small batteries. Anna, please let us enter the world of battery recycling.
Thanks, Frida. Well, I'm standing here at the core of the small battery sorting at the Stena Nordic Recycling Center. About half of all the small batteries in Sweden are sorted here. That amounts to about 1,500 tons per year. As you can see, they are taken care of in a fast and efficient way. There is a huge number of different types, and therefore it's important that we're careful. As well as containing valuable resources, some battery content is classified as hazardous waste. This must be separated out and disposed of in the right way, so it doesn't end up in the wrong place, in landfills, or even worse, out in nature. The batteries we sort here come from almost every part of the country. 80% of them come via the National Battery Collection System. The rest come from electronic products of all kinds, from both homes and companies. Part of the sorting is done with the aid of automated processes designed by Stena Recycling's own engineers. However, many batteries look the same, even though they have different contents. Therefore, part of the sorting must also be done by our knowledgeable staff. The result is well-sorted fractions, which are vital to successfully recycling as much material content as possible. At present, we reach a recycling rate of 74%. Why not 100%? One reason is that some batteries are unlabeled or incorrectly marked, which means that we cannot sort them correctly. Another problem arises with batteries that are so integrated into a product that we simply can't remove them in a reasonable amount of time. These are sent for destruction instead of recycling. We're convinced that we can reach a 100% recycling rate if we collaborate more effectively. We promote recycling knowledge and expertise and can help manufacturers at the design phase to make their products more easy to recycle. If a standardized labeling system is established for batteries, we can also sort and process them more efficiently. By working together, we will achieve the best results.
Thank you, Anna. And thank you, everyone who are logging on to watch this event. And thank you to you who are sending in your questions and comments. Because you know you can do that, right? You can send your questions and comments by emailing info@stenarecycling.com all throughout the event today. And all of your questions will be gathered and answered through a published Q&A on the event website. But now, Polestar is a Swedish electric car brand that grew out of Volvo's high-performance engineer arm a few years ago. And as an independent brand, they now have set high ambitions for climate, circularity, transparency, and inclusion. As their most ambitious initiative, the company has determined to develop a climate-neutral car by 2030 without using carbon offsetting. So therefore we say, welcome, Lisa Bolin, Climate Lead, and Sander Yahilo, Circular Lead. Hi, you guys.
Hello.
Hi. Welcome here. If we dive right into it, Lisa, why is this journey towards net zero so important to Polestar?
Well, first of all, we see the situation we're in, the climate crisis that we are in now, and we know that the world needs to do a big change until 2050, actually becoming net zero as a world in 2050, sorry. So for us, a goal that to make a carbon neutral car is actually in line with that, and something that we think we need to do to show that it's possible to do that. And also to set up high goals, it really boosts innovation. which I think for this forum today is also really important, that we need to solve also the hard parts. We cannot only pick the low-hanging fruits anymore. So I think that's something that we now have to face, the challenges that are also hard to solve.
Yeah. And how important would you say that the use of different raw materials is in general for the overall carbon footprint?
It's actually very important. I brought a picture today that you can see on your screens. And this is from our life cycle assessment of Polestar 2. And we compared it to an XC40 ICE. That's a petrol car in a similar size. And to the left, you can then see that for the petrol car, the use phase, of course, the orange part here is a very big contributor to the carbon footprint. And that was basically how it was for cars. Tailpipe emissions was basically the emissions that we focused on. But for the electric vehicle then, a Polestar 2, for example, the use phase, if you look to the right, when we charge the car with renewable energy, we can see the use phase is no longer the big emitter, but that's the raw materials, and that's the gray parts you can see here. The smaller gray part, the battery itself, and also all the other raw materials like aluminium and steel going into the car. So as an electric vehicle company, this is something that we absolutely need to focus on to solve.
So Sander, how can the use of recycled materials support your goal?
So I think recycled materials have a super critical role in this, because we know from research, everybody knows this, that recycling processes tend to take less energy. In the case of aluminium and steel, it could be 10 times lower, the energy consumption and the CO2 footprint for those materials. So it's super critical to have a lot of that in the car, because that helps us to get to a carbon neutral car. But of course, the issue is that the automotive industry itself is not a source for its own valuable metals. So we are using very high grade materials, but we use different grades of materials, of mainly the metals, and those then in the recycling or end of life phase get kind of gathered together and recycled as one big clump. So the result is a downcycled product, which is maybe useful for the construction industry, but not usable in the cars. So we really have to strive for making these closed loops, closed recycling loops for the automotive sector, so that we get those valuable different grades of metals back into the cars again.
And when it comes to batteries specifically, what's the path forward to make the batteries circular?
Yeah, I would say there's multiple ways to tackle it. It's a hugely complex product to solve. But I think there's three elements mainly. There's like one is obviously designing for circularity. So the way the battery is made out of modules, cells, packs, it plays a critical role in how you can repair the different parts of the battery, how you can disassemble it. So we know we have cell to module, cell to pack, and cell to body approaches. And I think there is a lot of kind of room for innovation and further discussions on which are the most circular ways of designing them, because if you have a cell to module battery, you can replace those modules, and that's good from a circularity perspective. You don't have to replace the whole battery, but at the same time you add weight into making those casings for the modules. So in the long run, there are studies which show that you could actually end up having a bigger environmental or energy impact and footprint if you have more modules rather than having a lightweight battery which doesn't have any modules. So that's one element that needs to be solved.
Yeah.
The other is, of course, getting all the recycled content into the batteries. And we know that the current state is quite bad. It's less than 1% of the batteries on average that contain, there's 1% of recycled content in the batteries.
Yeah.
So that needs to increase. But there, of course, we face the struggle of not having enough old batteries on the market to recycle. So that's an issue. And I think traceability is something that would allow for higher circularity, and this is what we do at Polestar as well, and want to increase so that we are able to measure the CO2 and the energy consumption down to the raw materials, the minerals in the battery. So just to get the learning of like where are the weak points and barriers, and where can we look for improvements.
It's definitely an ongoing process and a complex question. How important is it for you to keep control of the lithium-ion batteries in your cars throughout their life cycle?
I mean, it's very important if we see a future of recycling and maybe reuse of batteries. I mean, we are responsible for the product we put on the market, so also we have to do this. Since the battery is such a high value product that we put in the car, maybe the most expensive component, and also in terms of environmental impact, as you saw on my picture before. It's really important. It's going to be much easier for us to use this resource as the battery is in a more efficient way if we have more control over it throughout the life cycle.
Yeah, I can just add that, as you said, that we have the EU battery legislation, which will require us to be responsible for those end-of-life batteries. So if we are not able to control and maintain their presence in the markets where we operate, that's a huge problem, because then we could face battery leakage. Those batteries ending up in markets where there's no recycling facilities, but there might be self-starters who might want to capture some of those valuable metals, and that might pose huge environmental and social and health impacts. So there's a really crucial need to prevent that battery leakage from happening.
Senator, what would you prefer? I know this is a hard question, but if I make you choose, would you prefer batteries to live as long as possible, including, of course, reuse and energy storage solutions, or recycling as soon as possible?
I think from a circularity perspective, there is no question it should be going into a second life, because that consumes the least amount of additional energy and resources. So there's no question from the sustainability perspective, there should be a second life. There's kind of two things that work against it, potentially. Maybe in the future they will not, and maybe the situation right now is not so stable yet either. But there's legislation which is driving for increasing the recycled content of batteries. And for battery makers to achieve those targets, they want to get those batteries back as early as possible after the use in their first intended use cycle. And that's a problem, because then those batteries, they will not be able to go to that second life use, because there's a higher demand to recycle them earlier. And I think the third thing is kind of having the economics play out with this. We know that the price right now for second life batteries is quite high. It's higher than the recycling value, but that's also because there's so few old electric car batteries on the market. So we see that there will be a demand increase for energy storage systems and second life batteries, but also supply of those batteries. So where will they find parity? That's kind of a question we will see in the future.
Do you have any tips for other companies, maybe in the audience, where to start or how to start if they want to embrace a similar journey?
I mean, first of all, like I mentioned before, to set targets in terms of climate that are in line with science and what IPCC and other organizations that we trust tell us, but also to do mapping of your emissions and focus on some big topics. Like batteries for us, of course, is a huge question, together with aluminium, steel. Otherwise, I think you can get a little bit overwhelmed in the beginning. So targets and prioritize in the beginning, I think.
Yeah, I would just add on top of that do the same as Polestar did when Lisa started this, to do an LCA of your product, because that gives you so much information about where your kind of barriers and bottlenecks are, and that gives you the kind of baseline of what you should be tackling and what strategies you should be developing. So I would recommend that as a first step.
Okay. Well, thank you so much for sharing your experience, and we will follow your journey towards zero with great interest. And now, you guys, we are about halfway through our program, and it's time for a leg stretcher. I think you should use the next 5 minutes to get a fresh cup of coffee or maybe some fresh air and move around a little, and we will be right back. Welcome back again here to Halmstad, Sweden. I hope you got that extra cup of coffee and moved around a little, and that you are comfortable now, because we have some exciting information for you for the last part of this seminar as well, of course. Our next guest is Mats Linder, who heads Stena Circular Consulting. This is quite a new part of Stena Recycling, created with a purpose to help businesses to become more circular. Welcome, Mats.
Thank you. It's great to be here.
Mats, what are your reflections on the electrification of society and the rapidly increasing use of batteries? How does this fit together with circularity?
Yeah, so the first thing I think of is that electrification is absolutely necessary for enabling the circular economy. I mean, the circular economy runs on renewable energy, and electrification is the main carrier of renewable energy, so we definitely need it. And that means that today is, or this time we're living in now, is very exciting, since it's so fast paced and moving in so many exciting directions. With that being said, there is always a risk from a circular perspective that a rapidly growing new industry leads to new challenges and problems, especially if we think about batteries and the kind of resources it needs. So I see a risk that we're creating just another very extractive and linear supply chain if we don't think carefully about what we're doing.
And I assume you keep a close look on that. Do you mean that we might use up too many resources?
Yeah, well, I think we will have a supply challenge at some point, unless we do manage to create the circularity for those key raw materials, as we've also heard that the plan is to do. But if we did continue as usual and grew batteries as is projected, we'd see demand of lithium, for example, which is of course a key component in lithium batteries, go from 250,000 tons today roughly to between 1.5 and 2.5 million tons just in 10 years, so by 2030. And since lithium is now mainly sourced from a few places in the world, China, Chile and Argentina, for example, provides 96% of all the lithium currently mined. It poses quite a few challenges and could put pressure on just the supply side, creating some risk for blockages. And I think every manufacturing business in the world has experienced what that feels like during the pandemic, maybe for other reasons, but I mean, so this rapid growth can kind of cause some challenges there. And then finally, since the EU is more or less entirely dependent on imports for these raw materials, we are of course extra sensitive. There are some projections that suggest that we will be in a supply-demand deficit already by the mid-2020s. So in a few years from now, we could see that our demand for critical raw materials such as lithium and cobalt will actually surpass what our surrounding markets can supply us.
But we are a generation opportunity here, right?
That is true, and that's maybe also the good news, right? That since it's such a young supply chain, we're kind of building it from scratch as we speak. We have all the opportunity in the world to get it right from the beginning, which is a luxury we don't have in many other supply chains, where we're dealing with problems that were created maybe 200 years ago, and that we need to now, in a very painstaking way, start to deal with. If we do this right, I think we have a lot of potential to create a very circular supply chain and raw material management in the battery system, which would be a completely different story. But we need to do it right from the start. We need to incorporate those circular economy principles in the way we set this up. And that goes both on the product design side, as we will talk a bit more about, but also the way we set up the system, the relationship between supplier, customers, and different actors. So there's a lot of things we need to do, and I think it's also, yes, an opportunity, but if we don't get it right, we will see ourselves in quite a troubling situation, maybe 10, 15 years from now.
But so let's talk a little bit about how circular economy can help getting it right then.
Yep. So as I mentioned and hinted at, design is key here, and we've also heard that earlier in the event, that we need to begin there. The way we design a battery, in a way, decides how much value we'd be able to recover from it at its end of life, or how much value we can't recover from it. So a lot of the sort of the ceiling potential is set already at design stage. That sounds simple, maybe.
Yeah.
You know, let's just design for circularity and everything is a-okay. But it's a bit like saying, and I will quote this from my old driver's license theory book, which became quite philosophical at the last page, saying, well, there should really only be one necessary rule for traffic, and that is everyone needs to drive sufficiently slow for any kind of situation, which, you know, that would be nice. But that would also put a lot of the demand on the single individual to make the exact right judgment all the time. And I think it's kind of the same if you talk about design for circularity. We need to have some kind of an agreement, some kind of framework of what that means. I believe that for batteries, as with anything else, we should kind of look at setting up a couple of basic rules, basic standards for how design for being able to recycle or being able to reuse or remanufacture should actually look. That is what we need if we want to really drive the development towards the circular supply chain. And it's one of the things that we in Circular Consulting also work together with our clients to help with.
Yeah. And where are we right now in that to set up those guidelines?
Well, if we talk about maybe the know-how and for circular economy more general, we're in very early days. I think as a topic, as most of the people tuning in will probably recognize, the topic has risen quite dramatically on the agenda generally for the last 5-10 years. And now almost everyone knows or have heard about circular economy as a concept.
Yeah.
And quite a few businesses, countries have some kind of strategy or some kind of plan in place with targets for where to go. But there's much less of the know-how in terms of how we get there.
Yeah.
So that's kind of where we are. We're at we have decided we need to do something. We know roughly where we want to be, but we don't have the map for how to get there yet. And if we look at design, there are some easy examples, maybe not easy to do, but easy to at least conceptualize where we could start. And the very easiest and almost like a hygiene factor we need to consider is disassembly. If you assemble something, you need to be able to take it apart if you want to recycle it or do something like that to it. Here at the Stena Nordic Recycling Center, one could say that that makes all the difference between whether something gets recycled or incinerated. Just like assembly and many other operations, disassembly and recycling requires labor. And because we're working in a material industry which can only have the margins allowed for the material by the material value, of course, efficiency in disassembly and all the other operations is critical. So if you make something that's too hard to take apart, it will not make economic sense to do it. And we've seen examples on batteries in particular where, for example, it's basically encased in glue. So you have like a mantle of glue surrounding the juicy parts that you want to get to, but you can't. So that kind of design goes directly to the incineration pile, unfortunately. Another newbie mistake, if you like, but critical for a recycler is labeling. You need to be able to read on the actual device what it is. If you can't, you have no idea. And for example, because lithium-ion batteries comes with an increased risk, it's too risky to even start handling a battery like that.
And there are no legislations that demands this yet?
So there is, the EU is working on a battery package, which will, I think, provide some well-needed references and kind of corner flags for this. But as far as standardization goes, I think we can do a lot more. If we come back to the design for disassembly part, that's one thing. Formats is another. I mean, we've heard about batteries, lithium-ion batteries now going into increasingly numerous and diverse devices. But it's a bit of a wild west out there in terms of design, whether we talk garden appliances or consumer electronics or so. And it would be nice to have some kind of similarity to the way alkaline batteries work, right? And AAA battery is a AAA battery regardless of who manufactures it. why couldn't a laptop battery at least come in a few different shapes and sizes, regardless of who manufactured it? So I think there's a real case for a serious discussion among manufacturers and suppliers about how to drive towards a more standardized world of batteries. Ideally, maybe without involving legislation, because that becomes quite a blunt, sledgehammer. So that's another important aspect of the design, I'd say.
At least we're starting the discussion, huh?
Yeah.
But those were some bad design examples. Do you have good ones as well?
Well, it would be the reverse of this, right? When you can easily disassemble something or extract malfunctioning parts, replace them with functioning parts. I think Sander from Polestar mentioned this, and how a lot of batteries are built up around modules. So that's a great opportunity to also treat them so like that in the end of life phase. And that goes for the whole device, by the way. Like if it's not the battery that's broken, but the device, don't throw away the battery. If it's only part of a battery that's broken and not the entire battery, don't throw away the whole battery. But this designed for ease of repair, refurbishment, or even remanufacturing, which becomes a few orders of complexity higher. But also that is, I guess, a core feature of the circular economy, that we do make things more complex by thinking of material flows in multiple pathways, multiple directions all at once. And I think the great opportunity can only be realized if we're also bold enough to envisage and drive towards an ecosystem that is a little bit more complex in terms of how we treat our materials.
Yeah. It seems like companies have a lot of work to do to design batteries better, obviously. But how do we make sure they actually make their way back from the user?
Yeah, now you're touching on one of the trickiest pieces of this. And we need to kind of think beyond the product themselves and about the actual business model, the way things are sold to the market, the way companies are making money in order to address that. And that is also a core discussion point and feature of a circular economy. So if you think about how things are sold today, it's basically, I give this thing to you, you give me money, it's yours now. We sell products, and business models are about driving volume of products. We make more money if we sell more items. But by doing this, and companies have specialized doing this for many years, that does not really require you to consider more sort of than the bare bones of whatever extended producer responsibility requires you to do. It doesn't require you to be an expert at the end of life, because by that point it's not yours.
Exactly.
Out of sight, out of mind, right? And instead, the responsibility in a way is pushed over to the user, which in many cases is an ordinary consumer that have a million other things going on in life than to be an expert in end of life usage or recycling. So businesses actually have much better knowledge about their products, obviously.
Yeah.
So they, in some cases, or in most cases, are a better natural owner of that product, at least when you consider the end of life phase. So with a different business model, which is very disruptive to the way things work now. I mean, if we talk about batteries, think of a battery as a service type business model. A manufacturer has a much bigger possibility to keep and retain control over that battery to some extent over its service life, which can come with a lot of benefits. Like you could monitor how it performs. You can use that data to make better batteries in the future. You can also be more predictive about maintenance, repairing that module before maybe it explodes and damages other parts of the battery, so you can be much more resource efficient while the thing is in service. And also you then have more of an incentive, actually a very strong incentive, to get the battery back. So you would set up more of a reverse supply chain. And once you have done that, you have many more options. You can choose to send it onwards to recycling if it is really at that stage. You can look at it, say, this can go into battery loops storage unit for a while for some spot treatment. And then, or you say, we can do actually with some with relatively low effort, remanufacture this battery to as good as new, not having to go all the way, to granulate the materials or make a black liquor that then gets, extracts various minerals. So the business model, as you can hear, is really a key to opening up a whole range of new opportunities. But it makes it increasingly complex. It's very disruptive compared to how business is done today. But I believe this is a job that industry needs to do. Battery supply chain, just as well as other supply chain, it's really necessary to create a circular economy for batteries. Recycling is great, but it won't be enough, and it also will be more expensive if we don't manage to control the flow at the end of life.
Thank you so much, Mats, for your valuable insights. So far, there are quite a few vehicle batteries that have been taken care of and recycled, but the volumes will come. And Stena Recycling is preparing by establishing battery centers in 7 countries, from Sweden to Italy. Let's see how a vehicle battery is handled in the right way and how it can be recycled. Mats Torring, head of new ventures at Stena Recycling, I know you have prepared something to show us. Mats, go ahead.
Thank you, Frida. We're now going to take a look at how we collect, analyze and process vehicle batteries. There are several stages a battery must pass through on its journey towards reuse or recycling. Safe transport of batteries for recycling is important. Most batteries we receive are in a good condition. And for the damaged ones, we have containers like this. Stainless containers that help us prevent accidents. All the batteries we receive are inspected and evaluated. They are all marked so that they are traceable at every stage. Traceability is really important for many reasons, and requirements are increasing. Here you can see a complete car battery pack. And this is an example of a module that's inside the pack. And these modules contain battery cells. And the cells and the batteries contain valuable materials, a mine of materials we want to get out to be able to put them back into new batteries. The batteries are also kept a safe distance apart. And we make regular check on, for example, the heat. And then the battery packs are opened by our experts. Daniel here is one of them. The voltage is measured in several places to make sure that the battery is safe to dismantle. A vehicle battery is heavy, sensitive, and can hold a charge of up to 600 volts. So safety is top priority. There are strict safety requirements for discharging batteries. Special equipment is used and our operators follow an exact procedure. Discharge modules are also short-circuited. The power that remains in used batteries is fed into our internal power grid and helps drive our recycling operations. Materials in the battery packs like steel, copper and plastic are separated out for recycling. We have specific dismantling instructions for each type of battery we deal with. Used batteries can still have a lot of capacity. They may no longer be strong enough to power a car, but if they have sufficient capacity, they can be reused for climate-smart energy storage. This extends the life of the product and delays the need to recycle it. Now I have moved to the location of our new battery recycling facility. Here, lithium-ion batteries from vehicles and electronic products will be recycled soon. And we will use a range of technologies to make this possible. Electrification in society is increasing rapidly, and this facility is designed to handle the increasing volume of batteries we expect in the years to come. Here we will recycle batteries from several countries, and one of the fractions that we will extract is the black mass. The black mass contains cobalt, nickel, lithium, and other valuable materials. In the next step, the black mass will be refined through advanced chemical processing. This is a climate-smart solution compared with using raw virgin materials in batteries. We need to reduce the pressure on Earth's rare raw materials needed for battery production. This is how we together can close the circle so that these materials can live on in new electrified products.
Thank you, Mats. Great to see that you are ready to take care of the rising number of batteries. Now, our next speaker has been studying the usage and development of batteries for a long, long time. He's heading a consultancy in London and has been working together with several companies from around the world for many, many years, always focusing on batteries. Please welcome Hans-Erik Melin. Hi, Hans. I give you the stage, the virtual stage, and the audience.
Thank you very much. Thank you for having me. And I think already so much why things have been said here. I think I will be confirming a lot of those things. I hope also to inject some urgency as well. I wanted to start with this picture, and this beautiful picture of wind farm in southern Spain, just to emphasize the connection between lithium-ion batteries and renewable energy. Obviously, with the use of batteries, or the increased use of batteries, we will also increase the use of electricity as a power source in so many more applications than what we have done before. And another connection is also that batteries, in fact, are enabling the use of variable sources of energy such as wind, tidal and sun. So it's a strong connection between these two. And if we look at the lithium-ion batteries, it's hard to overstate, in fact, how important it is for this development. What comes with the lithium-ion battery is a high energy density, which makes enables us to use smaller devices, and the batteries are lighter, and actually they last much longer than basically any kind of battery, at least of this size. Which makes them very important. And in fact, as we've been talking already about here today, I mean, we use lithium-ion batteries in basically all kinds of devices. And all of us are using lithium-ion batteries every day. And as I think all of us know, we will use it in even more equipments and in more devices in the near future. And I would claim that the lithium-ion batteries, in fact, is maybe one of the most circular products that are there in the world. However, a lot of people would disagree with me. And we basically read every day, or at least every week, about how the green revolution is not as green as we might think. We read about the dirty secret of clean energy, the dirty secret of the dark side of the electric vehicle. And for sure, there are a lot of concerns that has to be addressed seriously, and that is already, of course, happening. One of the most obvious and important and serious ones is the working conditions and use of child labor in some extractive industry for some of the minerals in some parts of the world. And that is really serious. And it's something that the industry is working tirelessly to solve. Usually it has to do with poverty. And it also is, I think it's just important to recognize that this is something that happens in all extractive industry, not only in extractive industry. It's happening in farming, gold mining, tin mining. So we all have a huge task to really solve these issues. That doesn't mean that we can shy away from it in this sector. But it's not batteries that causes poverty. It's not batteries that are causing the problems we see in the value chain. But we definitely can try to solve it. Another issue we often also hear about, and we heard from Polestar today, is obviously the CO2 footprint from the batteries, which means that already when you haven't been driving a mile yet, you have a lot of embedded CO2 in the battery. And this is obviously also something that we have to take very seriously, and the good thing that it's just what's happening not least by using more renewable energy. In fact, electrification in itself is one part of the solution to actually make the supply chain greener. And it is happening not least when we're moving a lot of the production to Europe, but in fact also even in the countries where most of the batteries are produced today, we see a lot of greening of the actual supply chain. A third so-called pillar of the dark side of the electric vehicle is the lack of recycling. Recycling of lithium-ion batteries, sometimes it is considered as basically non-existent. We basically every week we read about these mountains of toxic waste you can expect from the electric vehicles when they reach end of life. And compared to the other two very important issues, I would say this is just not true. You all have recycled materials in your batteries today, and you have had that for more than 10 years, maybe 20. We have been recycling batteries for a long time. We might have not recycled a lot of batteries here, and I will explain why. And also, one of the reasons we haven't so much recycled content is that there haven't been that much batteries to recycle. One very important aspect to understand with lithium-ion batteries is that you have most probably never touched one. Maybe in a power tool or a camera. But most of the lithium-ion batteries are in fact embedded and built into the devices they power, like mobile phones or laptops, which means that they don't really have a life on their own. They have they live the life of their applications. And what's happening with the applications will also happen with the batteries. The same is obviously true for the cars. So the batteries live the life in the cars and are in fact rarely replaced because they usually or at least we believe so. They haven't been that on the market for so long time, but we believe they will outpace the life of the vehicle. This is one of the first vehicles in electric vehicles in London, and here you can actually see that the vehicles we placed on the market in 2010, 11, and 12, they are still in the streets. They are still used, and they have fairly high values. So they will be there for a very long time. Another thing with the lithium-ion batteries, as I said, is that they live the life of their applications, which means that these applications are also traded around the world. And there is a huge demand for the products that these are powering. And these products, these usually leave Europe and they go in particular to Asia, where they are remanufactured, refurbished, and redistributed all over the world again. Some of the batteries will stay there, be recycled there, but they are not here anymore. That's also very important. Another thing with lithium-ion batteries is that they are repaired. Like in this repair shop in Oslo, e-bike repair shop in Oslo, or these remanufacturing facilities for electric vehicles in Oklahoma, that obviously also extend the life of the batteries. And as we also been talking about today, they are reused and they are repurposed. They are reused in the applications from where they originally came from, something we see in particular today for Nissan Leaf, for instance, which is now out on warranty. So now there is a need for batteries to go back into the vehicles if somebody needs a replacement battery, and they are usually old. And then we have repurposing, as you are using these batteries for other kind of purposes. And one very popular, which maybe is where we see the highest demand for a lot of end-of-life batteries, is to convert electric vehicles, to convert ICE vehicles into electric. So these beautiful old Porsches or Volkswagens or whatever, now they are equally beautiful, but they're also clean and silent as electric vehicles. Then batteries are recycled. But as recycling really works best when it's close to production of batteries, that means that is also where recycling is taking place. And in fact, we haven't really for a long time been producing batteries here in Europe. So more than 2/3, maybe 3/4 of the battery production in the world is taking place in South Korea and in China. And that is also where most of the recycling has been taking place. Now, a lot of this is now changing, because if you look in this chart, to the right here, the last bar on that chart it's the first one in the chart to the right. That really shows the development we're seeing right now, where most of the batteries, which are the blue one here, were portable batteries, but now the growth is really driven by electric vehicles. And it's basically the same kind of growth, but it was completely different kind of applications. And what we eventually see now is that most of the manufacturers in Europe is now producing electric vehicles, and they are producing them here. And there will only be more of them. Most of the OEMs have 20, in some cases 30 models lined up for the next year that will be electrified, either full electric or electric hybrid. So there will be a lot of more production. And with this comes obviously production of batteries. More and more production of the batteries will be done here, both by homegrown producers and by Asian producers that open shop here in Europe. That means that everything is changing really in terms of how recycling can work in Europe. Another thing that also changes is the actual advanced batteries that we have in the vehicles that can be used for so many other kind of applications. It can add modularity, flexibility that makes it even more easy to innovate around this, which has given us many more applications, more batteries, obviously, in micromobility. We were talking before here today about garden tools, power tools. We can use batteries to make other kind of transportation more efficient. And we see a lot of disruptive solutions like this beautiful, or not beautiful perhaps, but very nice delivery robot that brings your pizza. And finally, we will have flying cars. We all wanted them for 20 years, and now we have maybe 100 companies that are developing vertical takeoff and landing vehicles based on batteries. So we are really getting into a battery economy where the battery will be as important as the semiconductor has been for the electronics industry. Now, this is not without challenges again. We are already talking about some challenges, but I will try to emphasize a few others. And Mats were talking about the scarcity of the materials. And I totally agree that what we are seeing today is that all the plans, all the announcements from battery producers, from car manufacturers, they're not really translated in sufficient investments in the supply chain. So we will definitely see shortages of materials, and individual companies will definitely see shortages of both components and of materials. To the right here in the chart, you see only the last 18 months of the price development of the materials in the most common lithium-ion battery chemistries. And it's obviously going in one direction. So again, we have already heard it today, resource efficiency, to really take care of what we have. And in terms of recycling, obviously, I mean, already today we need recycling solutions as in R&D batteries, so in the design phase and the production, there we generate a lot of waste, where we really have to squeeze out as much as possible to turn back as soon as possible into the value chain. But it's also about the design of the batteries, whether the batteries have to be as big as they are today, because it's really about being smart now and realizing that in the next 10 years, it will be a shortage of materials, either you want it or not. Another thing we will already be talking about is that they last for a long time, these batteries. Maybe much longer than what people expect. The case is that actually, if you compare the recycling rate as recycling compared to what is placed on the market today, it will actually decrease. There will be less recycled compared to what is placed on the market in the next 10 years, only because we place the batteries in devices which last much longer. And this have huge impacts and make it very difficult to be circular. Obviously, it's a great thing. It's a fantastic thing, of course, that we can use these batteries for such a long time. But it's also very difficult to be a recycler or a reuse company. This is models where we're looking at the most common ICE vehicles in the US. And we looked at the actual mileage over 20 years in these cars. most of the cars actually will be 20 years. Maybe not in your home market, but many of them will be exported to other markets and they will be 20 years. And if you apply what we know about the batteries to this driving behavior and the mileages, they will last in the most cases, for 20 years and even more. So it will take a long time for the end-of-life batteries to come back. And as I mentioned, the whole world wants electrification. It's not only in Europe and in the US or in China. In Ukraine, Russia, Jordan, in Sri Lanka, Dominican Republic, Costa Rica, they are buying a lot of electric vehicles, usually from the markets where they originally were placed. So that obviously means that a lot of vehicles will go elsewhere and will not turn up for recycling here. What's the solution for that? Well, we actually discussed it before here, and I mean, again, this is a great thing. We want electrification all over the world, why wouldn't we? But in the same time, obviously, we also want to create the circular solution, make sure that the batteries are well taken care of, and that we can grow the industry here, of course. I see Second Life, maybe not, we shouldn't call it Second Life really, because I see that as a solution. Not so much to take care of old batteries when they are not good enough, but maybe to actually replace the batteries when they are newer, that are better. And to take care of those older batteries and make sure that in an ordered fashion they can be used in other kind of applications. It's really about monetizing the battery to make sure that you make money as much as possible, so for as long as possible, of that very expensive battery. And the biggest waste of all is maybe the large battery we have in our vehicles. For some, it makes a lot of sense. If you're an Uber driver, taxi driver, absolutely. A salesperson that has to drive long distances, yes. But for me, who may barely have a commute, or I mean, most people that are driving like 40 miles every day for the daily commute, 80% of the time, they don't need this kind of battery. And we put a lot of resources into these batteries in times when we know there will be shortages. So there are solutions for that as well, of course. And I think it's really interesting to look at solutions like battery swapping, maybe battery swapping using different kind of capacities when you actually need it. We see it in micromobility, and micromobility in itself is also a very important solution, of course. So maybe you don't need 2 or 3 cars in your household. You can actually use other kind of means for transportation. Vehicle to grid, that you are using the battery while in the vehicle. It's also something very useful and connects very well to the solutions that Rasmus were talking about before in terms of energy storage. And we have different kind of charging solutions as well. That we often talk about fast charging. That's something that will damage the battery. But maybe it's not that bad that we are damaging the battery. If we mean by damaging that we are using it, it's much better that we actually use the battery and then take it out prematurely and use it in other kind of applications. It means that you will retain control of the battery in a much better way. And this doesn't only apply to electric vehicles. It can be applied to a variety of different kind of applications. If you make power tools, can I use that power tool batteries, which I have a power tool at home, it's 2 years and I have recharged it once. I'm not using it that much, but still, could I use that in another way, that battery, over those 2 years? Those kind of applications that please help me use the battery more than what I do today. I think that is really key. So my main message, and I think that has been, that's come across already by the talks we heard here today, is really monetize the battery in a better way. And don't look at circularity only something that's happening when it comes to recycling or even reuse. Even in the use phase, there is a lot to pay attention to. I will end this with a warning, because I'm seriously afraid of a narrative we have in Europe that we are superior, that we are better than others around the world, that we are more responsible, we generate higher quality on our products, and that we have outsourced production because there are lower wage in other countries. That might have been true once. But today, when when we actually outsourced production, we also outsourced a lot of initiative to innovate. We outsourced the possibilities to make production more efficient, product development more efficient. And in fact, when it comes to batteries, and I think we have to admit also in electric vehicles, we are not really in the lead here. We are not in the driver's seats. And I think that we really have to address that. I think circularity, I think monetizing the battery is what is really left for us to try to excel at. That doesn't mean that they aren't already in other countries good at this, because they are. But I think it's so important because to really shift the business models towards this. And I think I'm really positive, in fact, and I think that we will be able to do that, and that we will have a very prosperous future. Batteries produced here, recycled here, and some clean air. Thank you.
Thank you so much, Hans-Erik Melin. So inspirational. Thank you very much. Collaboration is key, huh? You guys, our broadcast from Stena Nordic Recycling Center here in Halmstad, where you can tell there's a lot of action going on, has come to an end. I'm so glad that you watched. And to wrap this up, I would like to ask Marcus Martinsson, Business Area Manager Batteries at Stena Recycling, to join me. Hi, Marcus.
Hi again.
How do you feel now?
I feel really good. I think we have experienced a lot of useful information, and it has been a great day, I would say.
Yeah. Did this day meet up to your expectations? We started out about an hour and a half ago.
Yes, I definitely think so, and especially when it comes to the width of the information we have gotten from the producer side, from Polestar. We have heard about the value chain, the effects on the society, and we have had the recycler's perspective, a reuse perspective, and also we've been touching the legislation issue, and also talking a lot about information sharing. And the main message from this day that I have experienced is the need for cooperation.
And that need, do you think we addressed it when our different speakers?
I hope we did, and I guess the only one who could answer is our audience. And I must say that I also feel a bit humble, because the transition is enormous. The speed is phenomenal, as Hans-Erik showed us on the screens, and the point of no return has been passed. So we have to emphasize the clear message from Hans-Erik. If we want to achieve something here, we have to have speed in our actions. And I think the key to endure this, or to enable this, is cooperation in a wider perspective than what we have experienced earlier, where waste treatment has been waste treatment and products have been products, and there has been very little cooperation in between. And now we've suddenly faced a much more complex value chain, and the key is definitely cooperation.
And the seminar is one small step in that direction, right?
I hope so. I hope so. And from our perspective, we started this journey a couple of years ago, and we have asked all the stupid questions one could ask. And we have learned a lot. And we hope to be able to share some of this knowledge with the audience today. And I would like to ask all of you in the audience, if you have any questions or anything you wonder about, or if you would like to cooperate in any way, please do not hesitate to contact us.
Thank you so much, Marcus. And just like Marcus said, if you have questions, feel free to email them in. And thank you for the questions that you already have sent in. There will be a Q&A in the event website after the seminar. Also, please do take the time to give your feedback on this event. It would be highly appreciated, and it will only take a few minutes to fill out the short survey. It's easy to do. Just just click on the link here on the broadcast web page that will take you straight to the questionnaire. And with that said, we thank you for joining, and we say goodbye from Stena Nordic Recycling Center here in Halmstad, Sweden. Stay safe.